All right, welcome back. 4.4, first fundamental theorem of calculus. What we've been doing so far is we've been dealing more with indefinite integrals, some Riemann sums, some definite integrals. We had some properties last section. In this case, we are going to go through how to solve these and how to actually evaluate them. So, the first fundamental theorem of calculus basically says that if f is continuous on that closed interval, and capital F is an antiderivative of f on the interval, then we can take the integral from a to b of the function f of x dx and equals the antiderivative, and we can evaluate it at b. We can take the antiderivative, evaluate it at a, subtract the two, and that's our answer. That's our total area, exact area, underneath the curve, between the curve and the x-axis. So we're going basically, these are called vertical rectangles, okay? Later on, we'll talk about horizontal rectangles and how we can change the bounds and do that. If you did area of a curve last year, and volume and stuff like that, then you should have no issue with any of that. First example. So when we talk about power functions, so any power function is basically x to the n. Okay, when we take the antiderivative of that, we're going to get x to the n plus 1 over n plus 1. Okay, and technically there's a c here because there's no numbers, but if I'm going to say from a to b, then there's no c there, right? So definite integrals, there's no c. Indefinite integrals, you need that c as that constant. So this is x squared, but when I do the antiderivative, I get x to the third over 3. This line means I'm evaluating it from 1 to 3. Okay, so this means this here is our capital F of x. That's our antiderivative. Then I put the 3 in, and I get 27 over 3 minus 1 over 3, which is equal to 26 over 3. So that's what our answer is there. This one, I'm going to say it's from 0 to 4. It's supposed to be a 4 and a 0. Okay, of x to the 1/2 plus 2, and all of this is dx. And so I can do them individually. I can split the integral if I want to, but I don't really want to. So I'm going to just do this from right now. So if I add 1 to 1/2, that's 3/2. But when I divide by 3/2, remember I'm multiplying by the reciprocal, so I'm actually going to get 2/3. Okay? Plus 2x. I'm evaluating all of this from 0 to 4. And I get, if I put the 4 into here, I do the third power first, so 4 to the third is 64. The half just means it's square rooted. So 64 square rooted is 8. 8 times 2 is 16 over 3 plus 8. Okay. Then if I plug 0 into there, minusing it, I get minus 0, so just minus 0. And this is 24 over 3, so that's 40 over 3 is our answer there. Let's scroll on down. The antiderivative from 0 to pi of sine of x dx. Remember, we got to think about our derivative rules and everything, and so this is going to be negative cosine of x from 0 to pi. If you need to go back and review that, I suggest you do. And then I get negative cosine of pi minus negative cosine of 0, not theta. And cosine of pi is negative 1, but negative of a negative 1 is positive 1, minus cosine of 0 is 1, negative 1. That's going to be 2. And the whole goal of an antiderivative or an integral is if I were to find this is our capital F, right? It's our capital F. If I were to integrate this, take the derivative of this, so take the derivative, I would get what I started with. So we got to think about that. Make sure when you're doing trigonometry and e's and ln's and stuff, if you took the derivative of what you end up with, does it give you what you started with inside the integral? Alright, so just be aware of that. This is x to the third over 3 minus 3x squared over 2 plus x. All of this is from negative 2 to 3. So 3 to the third, that's 27 over 3 minus 27 over 2. Plus 3 minus, now plugged in the negative 2, that's negative 8 over 3 minus 412 over 2, yep, minus 2. And if I actually do this, let me find out what the answer is, mainly because I don't feel like doing the math. I should get, this is, I believe, should be negative 3/2, give or take. Not give or take, it should be exactly that, hopefully. And then minus, this should be negative 32 over 3. And then when I actually add those up, I should get 55 over 6. And that should be the answer. Hopefully you did the math as well and not just take me for my word, because we all know that's bogus. Then number 5, the function 3 minus absolute value of x minus 3. If I were to actually graph that function, okay, here's what it would kind of look like. And so it would look like that, and then it would look like that, all right? And what does that mean? Well, because it's an absolute value function, I'm going to need to split the integral from 1 to 3, and then from 3 to 4. I'll explain why. Hopefully it makes sense, but it probably won't, but that's okay. So if I get 3, it's 3 plus x minus 3, and all of this is dx, plus the integral from 3 to 4 of 3 minus x minus 3, dx. So the reason this is split this way is because this has positive slope and this has negative slope. If I split it right where the vertex is, if I went from, if it was not an absolute value function, then I wouldn't need to split it. But because it's absolute value and my slopes are changing, and therefore it's a different function, right? It's a piecewise function. The two pieces are going to have different slopes. And so the slope of this first one is positive. If I actually take this and do this, this is just x. So this is just x dx. Like I combine a 3 minus 3, right? But in this case, I do this and I get 6 minus x. So that means that up here, way up here, is going to be at 6. That's the y-intercept. Okay, right at 6 up there. And so that's why we have to change our, break up the absolute value to two different pieces. And so this is really from 1 to 3 of x dx, plus from 3 to 4 of 6 minus x dx. Okay, this is x squared over 2 from 1 to 3, plus this is 6x minus x squared over 2, and all of this is from 3 to 4. And this one here is 9 over 2 minus a half, plus this is 24 minus 16 over 2 is 8, right? And then I'm going to subtract 3 times that is 18, and then that's 9 over 2, so minus 9 over 2. And if I do the math correctly, hopefully I did this time, I did wrong last time, is 6.5. That's what I'm going to get when I do that. Let's go to the last one. It's a pretty short video. I did this video once, but it apparently didn't get saved, so I had to do it again. And that one was like 20 minutes maybe, and this one hopefully is a lot shorter. Okay, so velocity we know is v of 4 is equal to 5, and then the acceleration is this. Okay, and this should be a t, not an x. It should be a t in there. Okay, a t is equal to 7, and I want to find the velocity at 7. So what that means is I'm basically taking the integral from a to b of my acceleration, a of t dt, and that's going to be equal to v of b minus v of a, right? If I integrate the acceleration, I get velocity of b minus velocity of a. Well, now I'm going to plug in some values. I'm going to have to start from 4 to 7. Because this is what it's giving me, this is the initial condition of what it's giving me, I have to start there. I can't just say, I'm going to start at 0, because I don't know what 0 is. And then my acceleration is minus sine of t squared plus 1 dt equals, well, v of b is just v of 7, and that's what I ultimately want to find, velocity at 7, minus the velocity at 4. Well, I know the velocity at 4 is 5, so I'm just going to make that a 5. I am going to bring that 5 over, and I'm going to say, okay, well, this is the velocity, or the acceleration integral from 4 to 7 of negative sine of t squared plus 1 dt. Bring over that 5, I'm going to add 5, equals the velocity at 7. Okay, so if I can find out what this value is, I can add it to 5 and I get the velocity at 7. But, that's a big but there, I can't do the t squared plus 1 yet because I don't know u substitution and I don't know a lot of other different things so far. Now, you did from last year, but according to this year, I'm not going to introduce you to things so we haven't talked about yet. So I'm going to use my calculator for that piece. So I'm going to pull up my handy dandy calculator. wherever it comes, right there, cool beans. Gonna have to bring it back over. And if I do that, the integral from 4 to 7 of the function dx, how do I do that? I did math 9, okay? And if you want to, if I didn't, instead of hitting 9, if you actually go up to 9, it's the fn integrable. It's the function I don't know, integrated. I don't know what it stands for, but that's what you need to do. And when you do that, you type in from 4 to 7 of your function dx, and you get 0.1067. So that 0.1067, I'm gonna round it to 0.107. So 0.107 plus 5 is equal to v of 7. So therefore, v of 7 is equal to 5.107. Okay, that is your answer for this one. That's your answer for the last problem, and that's it for this video. Deuces. I'll see you in the next one.